All right, well, hello, and thank you all for tuning into another episode of the Professional Pricing Society podcast. My name is Terrence, and today we're going to be discussing B2B pricing in the era of AI and data science. Spearheading this conversation is a director at Gap named Vivek Anand. Vivek is an operations research professional with over a decade of expertise in leveraging machine learning and AI in pricing analytics and optimization. In his previous role as the director of science at a leading B2B pricing vendor, Vivek cultivated an impressive track record where he successfully developed analytically driven pricing solutions that led to revenue and profit growth for numerous Fortune 500 companies across various traditional B2B industry verticals. Additionally, his expertise extended to the niche industry segments such as oil and gas, legal advisories and subscriptions, and HR solutions, where he innovated price optimization frameworks for these industries. Vivek, how are you doing today?
I'm pretty good, Terrence, and it's great to be on this podcast with you,
Good.
which is really a leading marketplace for pricing ideas. So great to be with you.
Good, good. We're glad to have you. And let's go ahead and just dive right into this conversation. B2B pricing in the era of AI and data science. So, can you share with our audience a bit about your professional journey and delve into the specific ways your expertise in B2B pricing has kind of evolved over the years, just to kind of give everyone a better grasp of your background?
Yeah, absolutely. So currently, I'm director of advanced analytics at a Fortune retailer, Gap, where my team's mandate really is to optimize business outcomes. It could be profitability, productivity, actually, it's both, through use of analytics for the enterprise. So basically, my team primarily deals with application of data science analytics in pricing analytics, inventory analytics, buying analytics. And like you said, prior to my current role, I was director of science at a leading pricing solution provider. And in that role, I worked with a number of B2B clients across various verticals where I helped kind of build or improve upon their existing pricing programs
Hmm.
by developing machine learning driven price optimization solutions. I kind of also worked with, like you said, niche industries like oil and gas and
Hmm.
subscription legal solutions, where like you'd not find many academic or industry or scientific literature on how to use data science analytics
Hmm.
to optimize prices.
Hmm.
And to your second question about like how it has evolved, when I started in this industry like 5, 7, 10 years ago, it was
Sure.
like slightly different. The data science uses were like not prevalent.
Mm.
A typical price optimization solution like still constitutes segmentation, computing elasticity, and optimization. But all
Mm.
of those three components have evolved over time, right? So
Hmm.
previously, when I started, segmentation attributes were kind of decided by the business stakeholders. Like they would feel like, hey, these attributes are important. They will have like a short list of attributes, and you use primarily use like basic or simple statistical techniques to identify like which of those attributes made sense
Hmm.
and which one of those did not. And similarly, when you go to elasticity, again, it used to be like a regression and still is a regression, can be a log-log regression, linear regression, but those methods are not always appropriate all the time. So for example, there have been cases where you do not have enough data. And in
Hmm.
that case, you're trying to create a regression. Then like a few months in, you have new sets of data come in and all of a sudden your
Mm.
results are different because like one outlier can change it, right? So
Sure.
it's still a robust method, but the way it was used traditionally was not appropriate, is not optimal, if you will. And similarly, like price optimization, like there is this genre in this industry, but there are many, many places where this price optimization is basically a rules-based price setting, right? Like, okay,
Mm.
when this happens, do this kind of thing, right? So when I started, what I did was I started experimenting with data science algorithms. So basically, to get these things done faster and better. So I developed a new machine learning framework
Hmm.
that would quickly assess a battery of segmentation attributes. And then we are not just limited by what the business stakeholder thought they were important. So we could run data analysis, EDA quickly faster to
Mm.
understand like, okay, these are the dimensions on which you can slice the data. And then also assess their attributes. Sometimes like the hypothesis that we get from the business is not visible in the data, and we have come up with better attributes. So this machine learning framework can assess a battery of attributes in a relatively short amount of time.
Mm.
Similarly, for elasticities, I brought in like newer and faster techniques. I can talk more about these like later. like faster sampling algorithms that could converge and reduce the runtimes. And scale is a big problem, right? Like 5, 10 years ago, you were primarily dealing with like small amount of data on transactions, customers, products. That's about it, right?
Hmm.
And now we have like a lot of data, right? So how do you like go from having a method that was suited for a small amount of data to a large amount of data? So this is like net. There's a cultural shift where the clients, the solution providers, and the end users are kind of like not shying away from using data science and analytics, uh, and leaning on machine learning, data science to make faster and smarter decisions.
Hmm.
So that's like overall tectonic change that has happened
Oh,
in the landscape.
okay, awesome. That's cool. Now you do have a very extensive background in this, even though things have changed in the past 5 to 10 years. And you've been at the forefront of applying innovative data science and AI techniques in pricing. So, starting with segmentation, do you mind walking us through some fascinating instances where you have kind of harnessed AI and data science to create a more robust segmentation solution?
Yeah, absolutely. And this is such a great topic, actually.
Mm,
There are many such examples of it, and as we speak, like the one that comes to my mind is a customer where like they had like a traditional segmentation model. The customer had implemented a customer segmentation model for their own customers across
mm,
two dimensions, like how much their customers spent money over a year and what is the price they were like paying, right? Like a price index,
mhm,
which effectively kind of measures like, hey, this person paid below the average price paid by all customers or above, right?
mm,
And if you think about these two attributes, think of it as scatter plot, and these two dimensions will create like four quadrants, right? You break the customer base by spend, and then you further break it by the price index, right? So you have four clusters
mhm,
or segments, if you will. Now, the salesperson used to come to them and say, like, hey, I don't really like this pricing because I feel like these two customers are selling situations are similar. I feel the price guidance for one is very low and we are leaving money on the table, whereas others is very high.
mm,
And we are kind of like at the risk of not winning the business, right?
mm,
And this was a problem that like kept on repeating, and that sort of also erodes the trust from the end user, the person who's using the pricing solution. So the customer, like the business sponsor, came to us and asked, like, "Hey, like this is what we are hearing, and I kind of agree with what they're saying in their argument. Like, can you like make sense of why it is happening?" So again, like looking at the transaction data, it's very difficult to kind of like have a scatter plot and eyeball and say like, does it make sense?
mm,
So that was like one of the first use cases of data science like years ago, where I just like ran a unsupervised clustering algorithm. So basically, instead of telling the system like how many clusters of segments of data you need to create, go figure how many should be there. And the machine came back and said like, okay, there are optimal 5 clusters instead of
mm,
the 4 that the traditional segmentation tree was creating, right?
mm,
And then we did some further analysis, and we found that there was a cluster of customers or transactions that were not the top spenders or not the bottom spender. They were right in the middle.
mhm,
And then there was another set of customers that were like not paying the top dollar, but also not paying the rock bottom. So they were like right in the middle.
mhm,
And you partition that middle cluster into 4 segments the way the traditional segmentation was done.
mm,
Two customers with a very similar selling situation. One goes into a high price cluster, other goes in a low price cluster, right? And
mm,
that was the source of the problem.
mm,
So we did some further analysis and worked with the customer to kind of give them like, hey, instead of like doing this customer segmentation across these two attributes, like in the segmentation tree, maybe we have one attribute that like clusters customers, and you have those 5 clusters. So more a data science driven cluster segmentation.
mhm,
And that, like, lo and behold, the problem was kind of solved, right? So that was one good example. Another good example actually goes back to customer specific price. B2B, like as you know, is a very negotiated bilateral conversations, right?
sure.
So segmentation will give you a segment price, right? But again, there are situations within a segment that there are customers who pay the rock bottom or below the floor price. Like in
Mhm,
typical price guidance, you have a start price, which is like the best price that you expect to get. There's a floor price below which you don't want to go, and then there's a target price right in the middle, right? And there will always be transactions that are below floor. There will always be transactions that are above
mhm,
start, right? And we were dealing with a customer who was like typically into selling raw materials and stabilizing products for food and beverage industry. Uh, and they were like, hey, I want to build customer specific pricing for my customers because I feel like, hey, we are losing business or we are not increasing
Mm,
prices fast enough.
mm,
And a typical implementation of customer specific prices is like people look at like, okay, what is this customer within this segment has paid? And where are they relative to the segment price? If they're like way below the floor price, maybe slowly increase them to floor. If they're between floor and target, increase them close to the target, right?
mm,
So it's again a rules-based pricing, not a super scientific way of doing it, right?
mm,
And the customer was like, hey, can you come up with a more scientific way? So like what we implemented was like a very hyper-focused segmentation based on not the segmentation attributes that we use to segment the business, but instead of like within the segment itself, what is, excuse me, a hyper segmentation that we can implement.
mm, mm,
And I used like machine learning methods for that hyper segmentation that I'm talking about. And we were able to leverage like their purchase behavior, who are their end customer, to assess like how much is their willingness to pay.
mm,
And in this example, we learned that all things equal, you have three customers. One customer's end user is like adult food industry, like you and I, right?
mm.
Eating like packaged food. And then
Sure.
similar customer is making baby food and similar customer is making pet food. The
Mm.
willingness to pay for baby food manufacturer and the pet food manufacturer was significantly higher compared to adult food
Oh,
manufacturers.
wow. That's interesting.
And in that case, what we were able to do is like, okay, instead of going by like where they are in the pricing segment, let's go by their willingness to pay. So we
Mm,
were able to give higher price increases to the baby and pet food manufacturers compared to
mm.
adult food manufacturers. So like these are like hidden patterns that are like not visible, or even like the traditional segmentation methods will kind of like fail
Mm.
at identifying these trends and patterns in the data, which is like machines are very good at this.
Sure, that's really cool. That's a good point you make. Leaning on machine learning for these algorithms and for these hyper-focused segmentation components to
Mm-hmm.
further study the willingness of customers and how their willingness to, I guess, purchase certain products. There's a lot that goes into segmentation. Um, but can you highlight a few other instances where you effectively utilize, AI or data science to tackle complex pricing challenges? Because it kind of would be great to hear about the diversity of problems you can address in this particular space.
Yeah, absolutely. So, I mean, one thing I alluded to, like customers or like end users' willingness to like lean on data.
Hmm.
So, people are harvesting a lot of data, and like previously, like I said, you would have some transaction data, you would have some customer data, and then things like that, and then you build a model, right? Now, with more and more data coming in and more products being available to the customers,
Hmm.
the scope of data has really exploded, right? And if you continue using the traditional methods, then it will take a significantly longer time to find pricing solution or recommendations.
Hmm.
So, like, there are two challenges with the advent or the adoption of the data culture, if you will, right? One is like the scale of the problem has become much, much, much bigger, and the scope has become much, much, much bigger.
Hmm.
So like there was a time when like I had a customer who had like millions of segments because they were stocking like millions of SKUs, right?
Hmm.
And with customers like those, what you have is typically you have 80-20 rule, pretty much everyone actually, where 80% of your revenue comes from 20% of your products, right?
Hmm.
And if you are leaning on traditional elasticity methods, right? Let's just use elasticity as an example. We don't want to talk segmentation. Uh, and if you're trying to compute elasticity for those millions of segments, you're talking about running million regressions, right?
Hmm.
And those are really time consuming. And again, like I talked about, they are very prone to outliers. 80% of your business, like I said, comes from 20% of products. Still, that means that almost a large chunk of your business doesn't have enough transactions to
Hmm.
accurately estimate elasticity.
Hmm.
In that case, what happens is like if you're running regressions, first of all, for a thin or sparse segment where you do not have enough data, your results can swing from one way to other with like injection of newer data, right?
Hmm.
Like we can estimate like, hey, for this particular SKU, oh, it's not elastic. And then you have like few months of transaction data coming and all of a sudden there is few outlier and it goes from inelastic to super elastic.
Hmm.
That is not good. You don't want any of those. Uh, and the second thing is like if you are having like too much products compute elasticities, like millions of regressions, it's time consuming, right? So
Hmm.
to address these challenges, we brought in like two methods, right? One method was to be able to work with less amount of data. So most of the data science algorithms are data hungry. They need a lot of data to give good predictions.
Mm-hmm.
But there are certain algorithms that like deal with like less amount of data. So for example, a segment doesn't have enough data. Instead of like collecting data or climbing above the product hierarchy and compute regressions or elasticity at a product somewhere higher in the product hierarchy, right? You could
Mm-hmm.
like look at the closest SKUs
Mm-hmm.
that are like similar to the SKU we are dealing with, which doesn't have enough data. So there are scientific hierarchical methods which will go up and up until it reaches a certain data density and is able to compute elasticities accurately. The good thing about these hierarchical regression, which are like Bayesian in nature, you can have robust results, which doesn't change with like advent of a few data points, sorry, injection of few data points in the model.
Mm-hmm.
So stable, robust results. So that was one set of algorithms that we implemented, like, hey, algorithms that are like less data hungry and still have robust results.
Mm-hmm.
The other question or the problem was about scale, right?
Mm-hmm.
So previously, what you would do in traditional methods is just rely on accurately estimating elasticity of top or fast selling SKUs and just like give some elasticity number at a higher level for the remaining SKUs, right? So
Mm-hmm.
for you to be able to run that regression, you need a method. So like traditional older methods that
Mm-hmm.
ran these elasticities relied on algorithms that used to take a long amount of time. Let's just put like in some cases 50 hours for a million regressions.
Oh, wow.
Yeah, yeah. And we implemented newer algorithms, sampling techniques like, I mean, the new robust sampling technique is called like a new no U-turn sampling.
Mm-hmm.
Nuts is able to converge that same 50 hours of work in less than 5 hours. So it's almost like you'll see 90% reductions in runtime. And it's basically data science and machine learning algorithms that learn things faster and converge to a solution faster. So you can solve the problem of scale, you can solve the problem of accuracy being affected by a few data points using these techniques.
Hmm. I can imagine that comes in. That's very convenient in today's world, as far as the amount of data we have
Yes,
in certain
absolutely.
industries. Now, you've been instrumental in assisting various companies, including Fortune 500 companies, in building and refining their pricing programs. How do you even measure the tangible value of your solution? Like, how do you measure what that brings to the table? Are there any specific metrics or analytical frameworks you can share with us?
Yeah, absolutely. I mean, and honestly, like in my experience, not much attention has been paid to this topic in the B2B space.
Mm-hmm.
Typically, companies implement pricing strategies and don't really have a scientific method to quantify what is the benefit I'm getting out of this pricing program,
Mm-hmm.
right?
Mm-hmm.
So, and if you don't measure what you're working with, what is the benefit, there is no good way to improve the process, right? The pricing strategy, and in absence of which you are just like you cannot continuously improve, right? Like the continuous improvement relies on effectively measuring it.
Mm-hmm.
So, and this is a problem like I had to deal with multiple times. So I leaned on my like operations research background to and statistics background to solve for this problem, right? So I leaned on like traditional statistical techniques to develop store tests. So basically, what you could do is the crux of this method is that you can select a relatively small amount of products and a relatively small amount of stores to be statistically representative of the whole fleet or the whole business that we're talking about,
Okay.
right? And then implement a pricing program or a pricing strategy in that narrow set of products and store combination. Look at the benefit against another similar set of stores and products to see like how much of a lift you are getting out of it.
Mm-hmm.
And what happens from this is the key objective of this design is to achieving a kind of balance where the selected products and the selected stores are representative, like I said, and small enough so that like if something goes south, they're not affecting the whole
Mm-hmm.
business, right?
Mm-hmm.
And how you do it is you want to select products that are needed to ensure equivalence across like multiple dimensions, like business divisions. Like if you have like multiple business divisions, you want to have equivalence. You don't want to select products that are top revenue grossers
Mm-hmm.
and a business division is not represented. Similarly, you want to select products across product categories, different product velocities, product profitabilities, metrics like margin markup, even seasonality. So you can like slice the products based on those dimensions
Mm.
Similarly, stores, you can slice the stores and select stores from based on region, traffic, profitability, and performance metrics like store labor, size of the store, location, volume that store deals with. And
Mm.
then you can kind of form, with those pieces of information, you can formulate the optimization problem. Like, hey, with these dimensions of products and, stores, find me a combination that is representative of my fleet in terms of volume, in terms of revenue, in terms of representativeness across the dimensions that I talked about.
Mm.
And it will not be a perfect match. Like, for example, let's just say your product division one is 50% of your business. These methods can get you to like 48%, 49%
Mm.
representativeness, right? And once you have these, you're able to get like a near representativeness. And typically with these kind of tests, you can simultaneously test like multiple pricing strategies. And like in statistical speak, they're like A/B tests, but the design of it is like a little more nuanced to achieve equivalence. And yeah, and once you have these tests, you can like come up with multiple pricing strategies, implement those at a smaller scale, understand the benefit out of it, and then like depending on which ones are working versus not, you scale up, right? And
Mm.
quantify the benefit of it. And if it's not working, you can continuously assess like, okay, does my pricing program kind of needs a refinement because the benefit that I was seeing over a period of time has kind of stagnated or like going down. So it just gives you a continuous read into how your
Mm.
strategy is doing, and you can continuously keep on refining it.
Okay, now let me ask you this as well. In correlation to what you just said, the selecting products that aren't too heavily involved with the revenue. If it doesn't sell too much, it's not gonna make the company go belly up. How often do you run these type of tests?
Actually, you can run it uh, once in a while. Like, for example, if you have a new strategy, you can run this test like as a one go see, like, hey, one time, 6 weeks, 12 weeks test.
Mm-hmm.
And you need to have like the product store and the duration. And it's a
Mm-hmm.
statistical formula that feeds that. And it will tell you like, hey, if you run these tests for these long number of days with these number of products and stores,
Mm-hmm.
and you expect to observe X percentage of lift, here is how long it's going to take. You can run these tests as a one-off, or you can
Okay.
have a continuous, like as they call it, like a control study where you always keep a small set where you're not putting any of your current pricing strategy, and
Mm-hmm.
then compare it and continuously keep on checking. That is what I was talking about.
Okay.
Like,
Okay.
you can have these tests that can be one off to test a strategy, or these tests could be like continuously running over a time horizon,
Mm-hmm.
and you can continuously refine it. If there is like a product that is not included or is a new in your assortment, you can refine the assortment mix and then keep going.
Okay. Okay. And that's more of like a controlled testing. That makes sense.
That's
Now,
correct.
as it pertains to adoption, driving adoption, especially within sales teams, it's often a challenge when introducing a new pricing strategy, as many of us may already are aware of. What are some strategies or experiences you have successfully navigated this hurdle and ensured seamless integration within teams?
Yeah, this is a good example actually. A good question actually,
Hmm.
and a few that come to my mind, and like some of my customers like have like extensively spoken about it on public forums. So like basically like if you don't ask anyone, I mean, there is always a balance between trying to get the highest price with or not losing the business, right?
Hmm.
So you have to incentivize those instead of like incentivizing volume. Like for example, if your incentives for adopting the price is like, hey, how many transactions you can close? It's a race to bottom. Everyone will go to the lowest price that you're recommending and try to close as many deals as possible.
Hmm. Hmm.
However, if you're able to incentivize, like, hey, if you are like selling at a start price, your incentive is going to be wildly different than if you're selling at a floor price, right?
Hmm.
So we had some customers who were trying to optimize gross margin dollars while incentivizing number of deals done, and that was like counterintuitive. So
Hmm.
defining your sales compensation program is a good way to kind of drive adoption. The other is simply asking people for like why do they need a price exception. So for example, we had a customer where like they were seeing a lot of price overrides,
Hmm.
and what they did was this: added a simple widget where you have to select from like 5 or 6 reasons
Mhm.
why you think the price is not right and why you need an exception. And you cannot leave others or you cannot leave blank. You have to give a reason, and those are
Mm.
concrete reasons. And all of a sudden, the adoption increased because if
Mm.
people can select others or not give a reason, they will always like, oh, right, right.
Mhm.
And yeah, and I had one more customer. Actually, they were like pretty good in this sense. Like what they did was basically when you have a price that is displayed for the salesperson, and if you are not feeling confident about, there is a widget to explain. You hit that explain button. It says like, hey, your transaction is similar to these transactions that have happened in the last 6 months or a year,
Mhm.
and this is the price they have realized. So it and that kind of gave confidence to the salesperson, like, hey, the price that I'm going to offer is not gonna end up in a lost business. So
Mhm.
it was more like building confidence. So there are multiple things people can do, but what I've seen is rewarding the right things and not rewarding the wrong things, like things that are not aligned with your business or pricing strategy, is the most effective way.
Mm. That's interesting. That's good to
Yeah.
know. Now, I want to move briefly aside from adoption and just looking at beyond, things as aspects beyond pricing. Are there other areas within the realm of B2B commerce where you foresee the integration of data science and AI playing a pivotal role? Any emerging trends or opportunities that may be catching your eye?
Yeah, yeah. I mean, certainly, and then like I have seen that happen with some of my customers, and like a good example is just staying with the segmentation theme. Like you could use machine learning to cluster your customers into different profiles, right?
Hmm.
And I'll give you a more relatable example.
Okay.
So think about it like your customer has like builders, manufacturers, kind of thing. And then one of your customer base, you're able to identify like, hey, these guys seem to be doing transactions that makes it look like they are flooring contractors, right?
Hmm.
So you're able to create personas of different customers that you have, and machine learning algorithms, there are a bunch of those that can accurately classify or cluster those set of customers. Now, think about just one customer like flooring contractors.
Sure.
Now, in the flooring contractors, what would a flooring contractor buy? Will buy tiles, will buy reducers, transition pieces, stair noses, all the good things, right?
Mhm.
So you have a persona that, hey, of these customers within my flooring contractor customer base, uh, pretty much everyone buys 40 to 50% of their sales is on flooring type. 20% is reducers, stair noses, accessories, whatever you will. And then once you have that, you can use machine learning algorithms or even simple analytics really to say like, okay, are there any anomalies in these clusters? Like, is
Mhm.
there a customer who is buying pretty much the same number of floor tiles or same percentage of floor tiles that other contractors are buying, but is not buying reducers, transition pieces, accessories, right?
Mhm.
And you can identify areas of growth there.
Mhm.
So that's like a very good use case of like clustering similar customers together, and then within that cluster, identifying anomalies to find areas where you can grow your business.
Mhm. Mhm. That's cool.
Yeah, yeah. And then there is another example. Actually, I worked on this one with another customer. So I had a client who stocked like standard parts and also built custom parts like electrical panels and
Okay.
switchboards and things
Okay.
like that, right? And many times, like customers would come to them and say, like, "Hey, I'm looking for this part, XYZ part, right?" And that would often be the case that they didn't have the exact same part, but they had like a perfectly good substitute of it in the stock.
Mhm.
And it was very hard for them, manually cumbersome and error prone, to have that mapping. Like, hey, I have this product. Here are the 15 other products that are a perfectly good substitute and can be used in its place.
Mhm.
But for them to manually maintain that mapping across multiple products, and as their assortment grew or the product offerings increased, it was becoming harder and harder for them to keep that mapping or like maintain the list of substitute products that could go, right?
Mm.
So like I worked on like building a machine learning solution for them that will create this mapping by kind of identifying product attributes. Like you have a free-form text description, like, hey, this is a X volt switchboard, whatever. And then you have product attributes, descriptions, like free-form text, like I talked about. And it would create a similarity score based on like, okay, these products are similar to this product. And this is how like you'd manually create a mapping, but give that rule to machine to be able to faster and accurately figure it out.
Mm,
And that would create like a good list of substitute products. And in this case, what they had to do, I mean, of course, you cannot take human in the loop, like human out of this loop,
sure.
but the task reduced from like identifying products to like looking at, hey, here is my machine's recommendations. Yeah, 90% of these are fine, these percent are not right. So it
Mm,
reduced their workload, and it was like a good use case of machine learning in making your product offerings more robust, right?
okay,
Yeah.
that's good. Now, Mr. Vivek Anand with Gap, I want to close out and thank you so much for your time today. Before I let you go, you did provide a lot of key insights, a lot of knowledgeable wisdom, if you will, in the AI and pricing and data science realm, as it regards to B2B pricing, at least. For those who are listening and are interested in learning more about you and your resources, what you stand for, maybe where can they go to learn more about you?
That's a good question. I mean, like I'm available on LinkedIn, so like a good place is to just connect with me on LinkedIn and like
Okay,
reach out to me with your questions that you have, and I'm
okay,
more than happy to engage. But yeah,
okay,
I mean, I also am looking to like create a forum for myself. Like I mentioned previously, I not only deal with pricing, I also deal with inventory, like buying and supply
hmm
chain related issues, which are again like pretty prevalent in the B2B space.
hmm
And I'm going to like I'm planning to actually. So I don't have a name yet.
okay,
Have a domain of myself where I will be like sharing these ideas. But LinkedIn is probably the best way to
okay.
reach out to me or communicate with me.
LinkedIn and to kind of keep up with you on the latest updates about this project you're working on personally. That might be really cool. So
Yeah,
stay in the know. I'm sorry, go
yeah.
ahead.
Yeah, I was saying that, yeah, absolutely. Like, I mean, LinkedIn will be the first place where I'll like
Okay.
talk about this project where I have like, these things like
Okay,
snippets
okay.
of codes and use cases and things like that.
Okay. Okay, cool. Well, for those who are listening, stay in tune because he has great things in store for you all in the times to come. Until next time, we'll see you all later. Bye-bye.